Why Atlantic and Pacific Oceans never mix. Have you ever wondered why the Atlantic and Pacific Oceans never mix? Let's dive in. This captivating natural phenomenon intrigues scientists and nature enthusiasts alike, hinting at the complex dynamics beneath the ocean's surface. The Atlantic and Pacific Oceans, two of the Earth's largest bodies of water, boast unique characteristics. Their distinct properties, from salinity to temperature, play a crucial role in maintaining their separate identities. Salinity levels in these oceans vary significantly. The Atlantic Ocean has higher salinity compared to the Pacific. This difference in salt concentration contributes to the invisible barrier that keeps them apart. Temperature variations between the Atlantic and Pacific Oceans further complicate their relationship. The Atlantic is generally warmer, while the Pacific has cooler regions. These temperature differences influence water movement and separation. Density, influenced by temperature and salinity, is a key factor in oceanic separation. Denser water tends to sink, creating layers that resist mixing. This density gradient helps maintain the divide. Density variations play a crucial role in preventing the Atlantic and Pacific Oceans from mixing. Differences in water density, often influenced by temperature and salinity, create a natural barrier between the two oceans. The Coriolis effect, a result of Earth's rotation, influences ocean currents and helps maintain distinct water masses. This effect causes the currents to rotate differently in each hemisphere, reinforcing the separation. Ocean currents, driven by wind and Earth's rotation, circulate differently in the Atlantic and Pacific Oceans. These currents create a dynamic boundary, keeping the waters from mixing and maintaining their unique characteristics. The halocline, a layer where salinity changes rapidly with depth, contributes to the separation of ocean waters. This gradient acts as a barrier, preventing the mixing of waters from different oceans. Thermocline layers, where temperature changes sharply with depth, also play a role in ocean separation. These layers create thermal barriers that keep the distinct water masses of the Atlantic and Pacific Oceans apart. The physical land barriers, like the Isthmus of Panama, play a crucial role in preventing the mixing of the Atlantic and Pacific Oceans by creating a natural separation between the two water bodies. Marine life has uniquely adapted to the specific conditions of each ocean. Species in the Atlantic thrive in its distinct salinity and temperature, while Pacific creatures are suited to its particular environment. Scientific studies have provided valuable insights into why these oceans remain separate. Researchers use advanced technologies to analyze water properties, uncovering the complex interplay of factors that maintain this natural boundary. Visual demonstrations, such as animations and infographics, can effectively illustrate the divide between the Atlantic and Pacific Oceans. These tools help viewers grasp the scientific concepts behind the phenomenon. Real-world examples, like the stark contrast seen at the meeting point near Cape Horn, vividly showcase the divide. These examples offer tangible evidence of the distinct characteristics that keep the oceans separate. Human activities, such as pollution and overfishing, disrupt ocean ecosystems, impacting the natural boundary between the Atlantic and Pacific Oceans. Coastal development alters water flow, further influencing the delicate balance. Climate change poses a significant threat to ocean boundaries, altering temperature and salinity levels. Melting polar ice caps introduce freshwater, diluting salinity, and potentially merging distinct oceanic zones, disrupting marine life. Interviews with oceanographers provide invaluable insights into these phenomena. Experts can explain complex processes in simpler terms, making the science accessible to a broader audience, enhancing understanding and engagement. Summarizing, ocean boundaries are influenced by salinity, temperature, density, and human activity. These factors create a fascinating, intricate divide, essential for maintaining distinct marine ecosystems and their biodiversity. Encourage viewers to engage with the content by liking, commenting, and subscribing. Their support helps continue producing educational videos, exploring the wonders of our world and the science behind them.